Space weather. Imagine a world plunged into darkness. Communication systems fail, GPS goes haywire, power grids collapse. This isn't science fiction, it's a very real threat posed by space weather. In 1859, the Carrington Event, the most powerful solar storm ever recorded, struck Earth. Auroras blazed as far south as the Caribbean. Telegraph systems went haywire, sparking fires and delivering electric shocks. We live in a technological age, reliant on satellites, power grids, and communication networks. Understanding solar flares and magnetic storms is crucial to safeguarding our infrastructure. The Sun, our nearest star, is a raging inferno, spewing out a continuous stream of charged particles known as the solar wind. The solar wind isn't always benign. Embedded within it are solar flares and coronal mass ejections, CMEs. These events can trigger geomagnetic storms when they interact with Earth's magnetic field. The Sun's magnetic field steers these events. The Sun's rotation twists these magnetic field lines, creating regions of intense magnetic activity known as sunspots. Sunspots are cooler, darker areas on the Sun's surface, marking regions of concentrated magnetic energy. When the pressure builds up, a sudden release can occur, resulting in a solar flare or a CME. These eruptions are often directed towards Earth, carrying with them a barrage of charged particles. Our planet is protected by a magnetic field, a shield that deflects most of the solar wind. This field creates a protective bubble around our planet called the magnetosphere. Solar flares are sudden, intense bursts of radiation from the Sun's surface. Imagine 1 billion tons of plasma heated to millions of degrees, hurtling through space at millions of miles per hour. That's a CME. Solar flares can disrupt radio communications, interfere with GPS signals, and pose radiation hazards to astronauts and high-altitude flights. CMEs are even more potent, triggering intense geomagnetic storms when they strike Earth's magnetosphere. These storms can wreak havoc on our technological systems. CMEs are the primary drivers of geomagnetic storms. When a CME's charged particles collide with Earth's magnetic field, they transfer their energy, causing the field to fluctuate wildly. This disturbance creates a geomagnetic storm. The most visible effect of geomagnetic storms is the aurora borealis and aurora australis. These dazzling displays occur when charged particles from the CME excite atoms in Earth's upper atmosphere. However, geomagnetic storms can also disrupt power grids, particularly those at high latitudes. These currents can overload transformers, causing blackouts. The Carrington Event of 1859 stands as a stark reminder of the potential chaos that space weather can unleash. Telegraph systems worldwide went haywire, with some operators reporting electric shocks and fires. Auroras were visible as far south as the Caribbean and Hawaii. The Halloween storms of 2003 disrupted satellite communications, caused widespread GPS errors, and triggered brilliant auroral displays. These historical events underscore the importance of monitoring and predicting space weather. Scientists use an array of ground-based observatories and space-based satellites to keep a watchful eye on the Sun. Space weather forecasting is more challenging than terrestrial weather forecasting. While we can track storms on Earth with high accuracy, the Sun's immense distances and complex physics make predictions more probabilistic. Despite the challenges, scientists are making significant strides in space weather forecasting. New missions like NASA's Parker Solar Probe and the European Space Agency's Solar Orbiter are providing unprecedented close-up views of the Sun. Advanced computer models are constantly being refined to improve the accuracy and lead time of forecasts. Protecting our technological infrastructure requires a multi-pronged approach. Hardening power grids and designing satellites with radiation-tolerant components are crucial. Developing effective early warning systems is paramount. Public awareness and education are vital to building a more resilient society. With continued investment in research, technology, and public education, we can build a more resilient future, better prepared for the inevitable storms from our nearest star. The universe is a place of constant change and cosmic dance. As we stand on the precipice of understanding our Sun, we also stand on the brink of a new era of resilience. The storms from our nearest star are inevitable, but so is our capacity to adapt and thrive. Imagine a world where power grids are fortified against the sun's fury, where satellites are impervious to radiation storms, and where early warning systems give us the precious time needed to protect our technology. This isn't just a vision of the future, it's a goal within our reach thanks to the tireless efforts of scientists and engineers around the globe. Public awareness and education play a crucial role in this endeavor. By understanding the sun's behavior, we can better prepare for its outbursts. Schools, universities, and media platforms are pivotal in spreading this knowledge, ensuring that every individual is equipped with the information needed to navigate the challenges ahead. Subscribe to the channel and comment your thoughts below. How do you think space weather will impact our future technology? Together we can build a more resilient future, ready to face the storms and bask in the light of our magnificent sun.